Hi, my name is Aaron Goldsmith. I'm a tutor for actuaryexamtutor.com. Today we'll be reviewing the algebra necessary for the P exam. Let's start with sets. You think of a set like a bucket containing a number of items that all have the same type. You can either the item can either be in the bucket or not in the bucket. You can't have anything midway. So a set of integers 3 through 7, you can write down as writing all the integers 3 through 7 and then enclosing them within curly braces. If your set has a pattern to it, you can signify a continuation of that pattern using an ellipsis. So the set of integers is going to have two infinite sides that you can use patterns on, going decreasing by 1 to the left and increasing by 1 on the right. And then the third way we can write down sets is if we already know another set and the set we want is everything in that set that satisfies a condition. For example, if U is the set of all plants, the set of carnivorous plants we can write down this way. The notation, this E-looking thing, means that X is an item that belongs in the bucket U. So this is all of the plants, the X and U, and the colon is read such that X eats animals. All the plants that eat animals. We are going to use sets on the P exam in Venn diagrams, but more often just in probability. So anytime you want to take the probability of something happening, the way to describe that something happening is a set of all the outcomes that are possible that satisfy some condition. So we're going to be using that more later on in the course. So now we're on to algebra. This symbol here is a capital Greek letter S, stands for sum. You've probably seen this notation before. FOIL stands for first, outer, inner, last, and it's an acronym to remember how to multiply the sum of two things times the sum of two other things. You take the first and the outer and the inner terms and the last two terms, and you add them all together, you get the expanded version of this product. This FOIL generalizes to the product of the sum of n things times the sum of m things. The way to find that is you look at all the possible pairs of selecting one thing from the left and then another thing from the right. You take the product of all those pairs and add them together. That will be the expanded version of this product. Rules of exponents. There are 3 here that I have that generalize more commonly known rules about addition and multiplication. So in these analogies, we're going to change addition into multiplication and multiplication into exponentiation. This first line says that if you add A together B times and then add A to that C more times, you're merely adding A to itself a total of B plus C times. This exponential version is saying that if you multiply A by itself B times and then multiply that by A again C more times, you're multiplying A by itself a total of B plus C times. You can check these other two to make sure there aren't any mistakes. They follow pretty similarly. For inverse functions, a function is an inverse. F inverse is the inverse of F if the composition in either direction gets back to the input. The inverse function does not always exist, but usually all you will need to worry about is when it is an increasing or decreasing function. As long as it's increasing or decreasing, the inverse will exist. And you can think about the inverse function graphically as reflecting the graph of that function across the line y equals x. The function f of x equals a to the x is an always positive function. It decreases when a is between 0 and 1. That is, if a is between 0 and 1, multiplying by a will get you a smaller number. If you multiply by a again and again, it just continues to get smaller. And then if a is bigger than 1, it will get bigger. So this function, depending on the value of a, will be either decreasing or increasing. And so the inverse exists. We call that inverse the logarithm base a. So it's the inverse function of f here is log base a. So this is the notation for logarithm base a. Because a to the x is always positive, we're not dealing with imaginary numbers for anything on the P exam. And so a to the x is always positive. That means that the inverse function will never be will not be defined for negative values. This f of x, f inverse of x, is only defined when x is bigger than 0. We have two rules of logarithms that are just the same as these rules for exponents. It's just when you take the log base a of both sides, you'll get these. And when you're substituting, if anytime you see a to the power b, you put in x, and anytime you see a to the power c, you put in y up here on these exponential rules. And then you take the log base a of those sides, and you'll get these rules here. So you can also check that. That's all we're going to do for Algebra for P exam. Coming up is the calculus review, and I hope that it will help you. You could let me know, and that would help me out. Thanks for watching.